Welcome back. This is Algebra 2, Lesson 1.6, and we are going to do Video 2. We're going to finish up with examples 5, 6, and 7. Okay, on this example, we're going to solve an AND compound inequality. So we have solve -4 less than 6x minus 10 less than or equal to 14. Then graph the solution. The first thing you're going to do is write down the original inequality. So we have -4 less than 6x minus 10 less than or equal to 14. Now, when we work with equations, we have two sides. Okay, we have a left side, an equal sign, and then a right side. When we work with simple inequalities, we have two sides. We have a left side, an inequality sign, and a right side. When we work with AND compound inequalities, often we have three sides to a single statement. You have a left side, a middle side, and a right side. And so whenever that happens, we have to make sure that whatever we do to one part, we do to all parts. So for instance, in this case, we want the x in the middle. We want the variable to be in the middle. So if you look, we've got 6x minus 10 in the middle. To solve for x, we need it isolated. So we're going to have to add 10 to the middle, but we also have to add it to the left side and the right side. You're going to have to add 10 to all three parts. So we're going to add 10 to each expression. So we're going to have -4 plus 10 is less than 6x minus 10 plus 10 is less than or equal to 14 plus 10. Then we simplify. -4 plus 10 is 6. 6x minus 10 plus 10 is just 6x. Less than or equal to 14 plus 10 is 24. Okay, now looking at this, the x is being multiplied by 6, so to undo that we need to divide by 6. But when we do that, we have to do it to all three expressions. So we're going to divide each expression by 6. 6 divided by 6 is 1. 6x divided by 6 is x. And 24 divided by 6 is 4. And so we're left with 1 less than x less than or equal to 4. So our answer, the solutions are all real numbers greater than 1 and less than or equal to 4. The graph is shown below. So we have an open endpoint at 1 and we have a closed endpoint at 4, and we've included everything in between the two. Now we're going to solve an OR compound inequality. So we're going to solve 3x plus 5 is less than or equal to 11, or 5x minus 7 is greater than or equal to 23. Then we're going to graph the solution. A solution of this compound inequality is a solution of either of its parts. So what we're going to do is we're going to solve the first inequality, and then we're going to solve the second inequality, and then put both parts on the same number line. So we're going to write the first inequality. So we've got 3x plus 5 is less than or equal to 11. We subtract 5 from both sides, and that gives us 3x is less than or equal to 6. X is being multiplied by 3, so we divide by 3. It's a nice positive number, so we don't have to worry about reversing anything. So we have x less than or equal to 2. Now we move on to the second inequality. So we're going to write it out. So we get 5x minus 7 is greater than or equal to 23. We add 7 to both sides, and so that gives us 5x is greater than or equal to 30. X is being multiplied by 5, so we're going to divide both sides by 5. And that gives us x greater than or equal to 6, because 30 divided by 5 is 6. The graph is shown below. The solutions are all real numbers less than or equal to 2 or greater than or equal to 6. So we have a closed circle at 2 and everything shaded to the left. And then we have a closed circle at 6 and everything shaded to the right. Example 7, we're going to look at an application problem here. A monitor lizard has a temperature that ranges from 18 degrees Celsius to 34 degrees Celsius. Write the range of temperatures as a compound inequality. Then write an inequality giving the temperature range in degrees Fahrenheit. Okay. So the range of temperatures C in Celsius can be represented by the inequality 18 is less than or equal to C and less than or equal to 34. So remember, when you write it like that, where there's three little bits, that's a compound inequality. So we've answered the first part of the question. Now we're going to let F represent the temperatures in degree Fahrenheit. Now, to convert from Celsius to degrees Fahrenheit, you are going to use the expression 9/5 times F minus 32, okay, because that's the equivalent form. So we're going to start off with 18 less than or equal to C, less than or equal to 34. We're going to substitute 5/9 of the quantity F minus 32 for C. So 18 is less than or equal to 5/9 times, so put parentheses there, F minus 32 goes in the parentheses, less than or equal to 34. Okay, so to undo this, probably the easiest way to approach this is go ahead and take care of that 5/9 that's multiplying the F minus 32. So we divide by 5/9, which is the same thing as multiplying by its reciprocal. So we're going to multiply each part by 9/5. Okay, we multiply each expression by 9/5 because it's the reciprocal of 5/9, and that'll make it cancel. So 9/5 times 18 gives us 32.4, less than or equal to the 9/5 canceled with the 5/9, and so we're left with just F minus 32, is less than or equal to 34 times 9/5 is 61.2. If you want to pause and double check this with your calculator, that would be a good idea, just so that you can convince yourself that 18 times 9/5 is 32.4 and 34 times 9/5 is 61.2. Okay, that was the hard part. Now you're like, we want to solve for F, we want the degrees in Fahrenheit, and so we've got F minus 32, so we're going to add 32 to each part. So we're going to add 32 to each expression. So that's going to give us 64.4, because 32.4 plus 32 is 64.4. When we add 32 to the middle expression, the negative 32 plus 32 cancel out, and then 61.2 plus 32 is 93.2. So the temperature of the monitor lizard ranges from 64.4 degrees Fahrenheit to 93.2 degrees Fahrenheit. Okay, that's it for examples for lesson 1.6. Do the 3 problems to try on your own and have all this ready to hand in next time in class, and I will see you then. If you have any questions, please come by.